kind of history book of past climate change.
These tiny chunks of rock in the sediment hold the answer to the USA's frozen past and to its future. Deposited 10,000 years ago, how they got here is astonishing.
Icebergs carry all these rocks and they hold them inside the iceberg, and then they melt. As the iceberg melts, it drops its load, and that's how we find these big pebbles out in the middle of the ocean.
Icebergs once floated off the coast. As the bergs melted, the rocks they carried from the north sank to the seafloor. 10,000 years ago, much of North America is in the grip of an ice age. But what causes a big freeze? The answer isn't found beneath the geologists' feet, but over their heads, in outer space. The Earth orbits the Sun in an ellipse that gradually changes shape over time. The tilt of the Earth to the Sun also changes. Calculations suggested that the interaction of these changes could flip the climate from warm to cold and back again. It's called the Milankovitch cycle, after the man who discovered it. His orbital calculations showed that the Earth flipped from ice age to warmth 10,000 years ago, the exact age of the sediments Domenical has found.
It was shocking when the evidence came out that there was this very close correspondence between the astronomical calculations and then really the geologic record. People were just blown away.
But what about the future? The orbital effect is called the Milankovitch cycle because it happens over and over again. Domenical believes the Earth will be plunged into another global ice age within 30,000 years. If the last one is anything to go by, the next will be worse. Because in the last ice age, there were just 5 million humans. Now, there are 6 billion. Could we all survive? Ice sheets 2 miles thick could cover the land. Cities like London and New York may be buried beneath thousands of feet of ice. Global sea levels could drop 400 feet as water is locked up in ice. Freezing temperatures might last 100,000 years. The food chain collapses. Plants die as they are smothered by ice. Herbivores can no longer find food and die out. As civilization collapses and food and shelter become scarce, our base survival instincts kick in. Dr. Erwin Redlener at Columbia University is an expert in how humans react to catastrophic events. The bad news is, many won't make it.
The major challenges will be to how to keep ourselves from killing each other because of a natural event like a new ice age. Enormous migrations of people trying to escape from the extreme conditions have the potential of causing a tremendous amount of deadly competition for resources, for food, for water, for power.
Billions of people could perish as vast areas of available land are swallowed by ice. But many humans will survive the big freeze in belts of green, north and south of the equator. Here, agriculture will continue, but not enough to support the billions who will now begin a battle to control it. In a few green areas, humans will survive, but the population will be greatly reduced. Civilization as we know it will change forever. And the next ice age is unlikely to be the last. The great ice sheets will continue to advance and retreat, devastating life and civilizations. 250 million years in the future, it gets worse. Life will face an even greater threat and be pushed to the very brink of extinction. The seas will die, and the land will become desert. 250 million years in the future, having survived ice ages and perhaps even asteroid strikes, there now comes an even greater threat. The surface of the planet is completely unrecognizable. Life is being pushed to the brink of extinction. This terrifying vision of the future is caused by the same powerful forces that shape the Earth today.
Well, the impression we get when we look around today is that things are fairly stable. Mountain ranges are fairly static. They don't seem to be rising. Sea level, we think is rising, but we can't actually see it very much. But when we take a longer view, when we look over a period of millions of years and we speed the whole thing up, then we start to see things happening that we wouldn't have expected, which includes the movement of the continents, includes mountain ranges rising and falling. And they've been going on for millions of years. So winding this forward into the future gives us an idea of how these things may develop in the rest of the movie, if you like. So we can see the present as a single frame in this very long movie.
This geological journey into the future began when people were first able to see the whole world laid out on one map.
People have suggested for quite some time, since the 18th century, that there's a jigsaw-like similarity in the coastlines of the continents around the Atlantic, but I don't think they really had an idea that the continents had actually moved.
But in the late 20th century, scientists realized that this is exactly what they do. The speed varies, but right now, America is pulling away from Europe at over 1 inch every year, about the same speed that a fingernail grows. This continental movement is called plate tectonics. It reveals that the Earth's surface is made up of a series of massive continental plates that are in constant motion. Where they collide, huge mountains are driven up and massive volcanoes pour out liquid rock. It shapes the face of our planet. Armed with this new information, the geological record opened up like a book, revealing that 250 million years ago, all the continents were united to form a single supercontinent we call Pangaea. This was a hot, brutal world ruled by dinosaurs. Could future movement of the tectonic plates transform the Earth once again into a single vast landmass?
We now know how the plates are moving far more accurately than ever before, and so it became tempting to look into how this might develop if we projected these motions a few million years into the future.
According to Livermore's model, 250 million years in the future, a new supercontinent will form. Africa plows into the Middle East as Antarctica and Australia fuse together. One vast landmass surrounded by a giant ocean. With much of the land hundreds or thousands of miles from the ocean, rainfall becomes non-existent. No plants grow, and as the land absorbs the heat, temperatures soar. It turns to desert.
If we were looking down on the future supercontinent, what we're likely to see is something really rather like the interior of Australia.
250 million years in the future, this new world will be mostly desert, covering over half of the land. So hot and dry that few plants or animals survive. 80% of the species we see today could be wiped out. Those that do survive will have to adapt to less water, less food, and rising heat. Our distant descendants might try to take refuge in the coastal regions. But even here, there's no escaping the dangers of this new world.
Around the edges here, we're probably going to see continuing volcanism, continuing earthquakes.
The tectonic forces that pushed the supercontinent together